Welcome again to Math 800 Pre-Algebra. Today we are doing section 6.1 Ratios. Our objectives: 1. To write ratios as fractions. 2. To solve ratio problems involving decimals or mixed numbers. And 3. To solve ratio problems after converting units. A ratio can be written in several ways. For example, the ratio of $7 to $3 can be written as 7 to 3, or 7:3, or 7/3. In all cases, we actually read them as 7 to 3. So really, you should read this 7 to 3 and this 7 to 3. But these are the three different ways you can write the same ratio. Since we're a math class and we're going to be doing some math with these ratios, we're going to prefer the fraction. We cannot do math with words or a colon. So we will always write our ratios as a fraction, 7/3 in this case. Be very careful though. Fractions, the numerator and denominator mean different things, so order is very important when you're writing a ratio as a fraction. The quantity mentioned first will always be the numerator. The quantity mentioned second is always going to be the denominator. For example, the ratio of 5 to 12. 5 was said first, so it is our numerator. 12 was said second, so it is our denominator. The order is critical. You must have that correct. An example: ancestors of the Pueblo Indians built multi-story apartment towns in New Mexico about 1,100 years ago. A room might measure 14 feet long, 11 feet wide, and 15 feet high. Write the ratio of the length of a room to its width. So specifically, we're looking at the ratio of the length to the width. Length was mentioned first, so that will be our numerator. Width was mentioned second, so that will be our denominator. The length is 14 feet. The width is 11 feet. So we have 14 feet over 11 feet. Ratios, I should note, always have the same units. Our next section will be getting into rates. Rates have different units, but ratios will always have the same units. So we're comparing 14 feet to 11 feet. Since they're the same units, we can cancel them out, and we're just focused on the 14 over 11. You should try to simplify your ratios. However, you do not write them as mixed numbers. So 14 over 11 cannot be simplified, so we just leave it as is. You absolutely cannot write it as a mixed number. Ratios must be written as fractions. Another example: write the ratio of 60 days to 20 days as a fraction in lowest terms. So you have 60 days over 20 days, because 60 was mentioned first, 20 was mentioned second. They have the same units, so we can cancel them out. And now we simply have to simplify 60 over 20. We can divide both 60 and 20 by 20, and we get 3 over 1. That is our ratio in lowest terms. You should note, in Chapter 4, when we were working with fractions, we would have gone one more step and said 3 divided by 1 is 3, and your final answer should have been 3. In fact, some of you lost points on your last quiz and exam because you didn't take it all the way to 3. However, now that we are working with ratios, ratios compare two quantities. So we need two different numbers, a top number and a bottom number. So even though the bottom number is 1, we leave it there so that we can see what two quantities are being compared. Example: write the ratio of 50 ounces of medicine to 120 ounces of medicine as a fraction in lowest terms. So you have 50 ounces over 120 ounces. Again, the ounces are the same. We have the same units. That's why we're a ratio. Now we simply have to simplify, divide both top and bottom by 10, and you get 5/12. Now we'll look at some problems involving decimals and mixed numbers. The price of a Sunday newspaper increased from $1.50 to $1.75. Find the ratio of the increase in price to the original price. Be careful here. A lot of people just skim the problem. They see 150 to 175 and they assume this is the ratio. But notice, it says find the ratio of the increase in price to the original price. So neither of these is the actual increase in price. We have the old price or the original price and we have the new price, but we are looking for the increase in price. You have to do a little bit of work first. So to find the increase in price, you take your new price, subtract the original price, and you get your increase. This relationship, taking the new minus the old and getting the change or the increase in this case, is very important in mathematics and is very important in this chapter and our next chapter. If you do not understand this relationship, you will have some major issues. So, again, when you're looking for the increase or the decrease or the change, you take your new thing minus the original thing, and that will give you the change. In this case, it's an increase. So our new price is $1.75. Our original price is $1.50. When we subtract them, you get 25 cents. So or 0.25 hundredths of a dollar. So for our ratio of increase in price to the original price, the increase in price is going to go in the numerator, that's 25 cents, and the original price is going to go in the denominator, and that was $1.50. This is the ratio we're now going to simplify. We have the same units, which is what we wanted. Now, to deal with decimals, we want to get a ratio of whole numbers. So first we're going to multiply top and bottom by 100 to get whole numbers. Now that we have whole numbers, we will simplify these like normal. We can divide both top and bottom by 25, and I get 1/6. So the ratio of the increase in price to the original price is 1/6. In other words, the price increased by 1/6. Write the ratio of 3 1/4 to 1 1/2 as the ratio of two whole numbers in lowest terms. So here we are going to have to convert our our mixed numbers into improper fractions. So 3 1/4 is 13/4 and 1 1/2 is 3/2. So a ratio of 3 1/4 to 1 1/2, written as improper fractions, would be 13/4 over 3/2. Recall that this is a fraction and fractions are just division, so you can think of this as 13/4 divided by 3/2. These two things are identical. To divide a fraction, you need to multiply by its reciprocal. Now you could multiply straight across and have 26/12 and then simplify, or you can be lazy and say, well, 4 is 2 times 2. One set of 2's cancels and you wind up with 13/6. Write the ratio of 2 days to 2 1/4 days as the ratio of two whole numbers in lowest terms. So again, we have the same units and they cancel out. We will need to have just two improper fractions. So 2 can be written as 2/1 and 2 1/4 can be written as 9/4. Divide the top by the bottom. You divide fractions by multiplying by the reciprocal. In this case, nothing will cancel, so we just get 8/9. Solve ratio problems after converting units. Some problems will require that you convert units. These are the measurement comparisons that you'll use for converting units. You should have this written down somewhere for easy reference. As far as what you should have memorized before the exam at the end of the semester, you should have the length relationships memorized, and you should have the time relationships memorized. Many of you most likely have these memorized already. Capacity or volume and weight, I do not expect you to have memorized. Example, write the ratio of the length of the shorter board on the left to the length of the longer board on the right, compare in inches. In this case, they're specifically telling us to use the unit inches, so we're going to have to start by converting 2 feet to inches. Notice that 1 foot is 12 inches, so 2 feet is 2 times 12 inches. The feet is the same as 1 foot is the same as 12 inches, and 2 times 12 is 24. Therefore, this board is equal to 24 inches. And they wanted us to compare the shorter one on the left to the longer one on the right. And so we're going to have the 2 feet over 30, but we converted that to inches. Notice now that we have the same units, we can cancel them out. Ratios are always comparing the same units. Then you can simplify the fraction, divide both top and bottom by 6, and we get 4/5. So we could write this one as a sentence. The shorter board is 4/5 the length of the longer board. Our last example, write the ratio of 28 days to 3 weeks. Notice in this case they did not specify what units to use, so you can either convert 28 days into weeks or 3 weeks into days. In general, if they don't specify, it is a good idea to use the smaller unit, such as days, because then you will not wind up with any fractions or decimals. Not that fractions and decimals will kill you, but it will make your arithmetic somewhat easier. So 28 days is what we're going to be working with days. So 3 weeks expressed in days. 1 week is 7 days. So 3 weeks is 3 times 7 days, or 21 days. So now we're comparing 28 days to 21 days. Now that the units are the same, they cancel out. 28 over 21, we can divide them both by 7, and we get 4/3. I should note, had we converted 28 days to weeks, 28 days would actually have converted nicely without any fractions or decimals. 28 days is 4 weeks, so then you would have had 4 weeks to 3 weeks, which is just 4/3. So you get the same final result no matter which unit you convert to. However, if you want to work with avoid fractions or decimals, then you'll always go to the smaller unit. That concludes section 6.1. Your next steps are to complete the worksheet for section 6.1, then check the key in D2L, and then complete the online homework for section 6.1 through My Math Lab. After that, you should start on section 6.2.